this can watch it later. There we go. Recording started. So the point of this early morning, hopefully short, and hopefully somewhat dog barking free. We'll see how long it lasts. Yeah, not long, apparently. The point of this morning is essentially to do a very simple task, which is to create a small 2D space that represents a kind of a ground area that a building will consume at any given time. So the building will take up X amount of space, and this will keep us from building objects that are not kind of in the right place. It'll keep us from building things that cross edges and go off cliffs. So just to show off very quickly, ooh, or just to generate a giant freaking forest. Whoa. There's a bug going on here. Allow me to, okay, something unexpected already to start this morning off. Yeah, I broke something. Ooh, whoops. This is what I get for not testing my code. What I probably should have done, we'll just set this to like 1,000,000. Yeah, 1,000,000 seems good. So I set these to numbers that were actually probably outside of a valid range, which is causing them to now break, unfortunately. So I'm just kind of setting those back. There we go. Let's see if that fixes it. I made those changes without thinking much. There we go, that's better. Although you'll notice our terrain is completely flat. I think my partner might have broken something, or I broke something. So this is the wonderful thing about Subversion software. You can go back, and we're going to first off see if there are any updates. No. Okay, so there's nothing new. So we're going to go back, and we're going to actually look at the log of everything we've done and figure out where we went wrong. So you can see here's a fix from me, where I fix what I think is some random number range issues, and as it turns out so far, that is one problem that definitely needs to be fixed. Also, it looks like there's some other stuff that my partner added in. Also, I'm noticing that this offset is kind of having the same problem. So we're just going to go from the 1,000,000 to 1,000,000 and see if that, whoops, we also have to fix it here and here. And so the problem is that this random float is going from a minimum to a maximum number. And I was giving it numbers that were outside of the valid float range. Does that? Yeah, that fixes it. Okay, so now that I've fixed the game from my bumbling errors, we're just going to open up my Subversion software and oops. And we're just going to put that in, and that's number 96. Because I didn't mean to break things, but I still do from time to time. Hopefully it won't be all that bad when I continue to break things. Hopefully I won't break too many more things either. But without further ado, let's actually get to the thing I'm trying to get done today. So the idea is that we need a 2D space, and I'll open up the world again and see if I can do this correctly this time. So the idea is, here is our object that we want to place in the world. And there's some bugs with this. You can see moving the camera doesn't always update the preview. There's a couple other slight issues, but it's just visual problems that I can fix later. So we've got this, and when you place it down, I want to not be able to place it over things like this edge, right? That seems like a bad place to be able to put it. But when you click, it still is a valid place. So what we need to do is create some way to either have the author of a building generate a type of space, or we need to create some kind of calculated bounding box to ensure that everything fits on that bounding box. So the easiest thing I can think of is either if we add the user-generated space, just make it a little 2D plane that we can fit on things. Or if we generate the bounding box, we might just be able to do that nice and easily. Especially when it comes to the space that we need to put down. It might be possible for us to do some fancy things if we do user-generated. So I'm leaning in that direction for now, especially since user-generated is going to be a lot more predictable, especially for something like, I'll put a real shed down somewhere, something like these sheds, or this farmland, where the bounds are very obvious, right? Generating a bounding box for these should be nice and easy. It should be a little less simple for something like this generator. You can see the generator's got a couple models to it, and it's got some tanks on the side. I know it's a little hard to see. Let's set the time of day to something a little more reasonable. But you can see it's got a couple tanks on the side, and it's got some geometry here that might not play nice with a dynamically generated system. I'm not actually certain. Also, stuff like this little bit here on the end in a automatically procedural system will extend the bounding box when I might not actually care a ton if that ends up being something that gets kind of clipped into objects and that kind of thing. So let's just go with the user-generated for now. Let's do that. That seems like a nice, easy thing to do. And I've already got, let's see, somewhere here, I should say, I've already got some code files that aren't, you can see they're not part of the SVN repository. We're just going to add them into our project. And I created these recently, not too long ago. And it just has a simple class inside that is completely unimplemented and unfilled out, and the CPP file is nice and empty too. So we're just going to dive into this. So what we need to do the most, more than anything else, is kind of emulate something that already exists in the system. That makes our life nice and easy, right? We just, yeah, I know, the haircut. It's not as bad. The haircut was terrible when I first got it. You should have seen it. It looked like a bowl cut. I had to actually clean it up myself. It was frightening. Anyway, distraction. Hi, Mike Hunt, by the way. Good morning. People in chat are at least at least a little more awake than I am, hopefully. So they'll catch anything that I miss. We'll see. So we've got a fog space, right? The engine has a fog space. And in fact, I'll illustrate kind of what I'm looking for quickly before I even dig into the work. So, let's say inside this storage shed, so I don't really care about the edges where this roof sticks out, and I don't care a ton for this area over here on the side. So what we essentially want to do is set some kind of primitive down that says, here is, and let's see, let's put the material to something. That material's not actually playing nicely. Let's try the actual fog space I'm talking about. Since, you know, I am talking about it, I may as well demonstrate it. The hope is that, here it is, I can do something like this, where I put a space down, and I kind of highlight the most critical areas. So let's say I don't want that overhang to be part of this. So we'll take that out, and we'll extend it over the entire house. And maybe I don't actually want it to take up quite so much of the entire house, so I'll bring it in a little bit. And the idea is that this blueprint, which it's marked fog, obviously we would go in and edit it and make our own, but you can see how closely it matches the floor. That's really nice. And since it's just this 2D plane that doesn't really get rotated or messed with either, it should be a fairly simple thing for us to author and tell the engine this space that this house is sitting on, that is the minimum necessary space for us to put one of these down. We don't want any of these points being in a different cell from the other points. And remember, we're using those Verneuil cells, so that should make this even easier. We'll see if that actually is the case. So we want our blueprint space, and we can inherit off of, we might be able to either inherit off a current space subnode, or the other thing we might be able to do is we might be able to actually just kind of copy and paste a lot of code that currently exists for the engine's fog space, because that's mostly what we want, right? We don't want the graphical stuff that the fog space gives, but we want the data that that space contains. So it looks like everything kind of comes off of this, I should say, subclasses from a space type. So let's go from there, and we'll kind of build our way up, because you can see here's our fog space underneath, and it's a pretty simple thing. It just has a couple world vertices, and everything else is fairly simple matter otherwise. So we're going to subnode. Whoops. I don't mean to close things, I just do sometimes. And what was that? We need to include the file, obviously, where the space class is defined, so that it understands what we're trying to do. And we need an enumeration. K space blueprint. And we need to give it an identifier, so blueprint space. And for anyone who's wondering, I keep setting out enums that are equal to 4 character strings. And that's because if you look at this and think a little more in depth about it, each of these characters is 8 bits, and an enum is a 32-bit integer. So what we're doing is, very simply, we're telling the compiler that we want this enumeration value to be equal to this character ORed against this character, ORed against this character, ORed against this character, in such a way that here's the first 8 bits, the second 8 bits, the third 8 bits, and finally the fourth set. And so there's our 32-bit integer, but it's in a little more of a reasonable form for us as human beings, so that we don't actually have as many collisions, or so we hope. Obviously, I'm not keeping track of these too well, so if I do have a collision, there's likely going to be something that goes wrong inside of the system, and either the engine will tell me or a giant bug will appear. We'll see which one happens first. And this is a pretty simple setup, right? It's a .3D array of 4 of these. Right? That's really all we want. We just need 4 3D points to generate this plane. If we wanted to go even simpler, we could, but for now, that's a nice, easy format for us, and it keeps us from doing anything too clever or complex, especially at this hour of the morning when we would likely mess up something where we get a little too clever for ourselves. Alright, so we've got our blueprint space, we've got the world vertices inside. We need to figure out how to do a couple other things, because obviously this isn't complete. I can't just stick this into the engine as is. Luckily, I have already built a game tool, and this game tool, I'm actually going to bring up the panel for it. Let's see here. It's not actually in the game, it's in the tools. Interesting, it should be here somewhere. So I've already created the engine plugin that allows me to put this stuff down. And it's hiding here somewhere. Oh, here it is, plugins. There we go, where I should have honestly expected it to be. And we're just gonna duplicate one of the buttons here. And I seem to have put it in an interesting position. There we go. Let's get those in line with each other. And this will be our blueprint button. And we need to find an image that looks right for this. Because obviously some of these, I'm stealing all my stuff from the engine right now. All my buttons are actually just textures taken straight from the engine. And that's fine in most cases. But we actually need to create buttons for this eventually. Eventually I will move away from the programmer art, I promise. It's just something in the meantime that I'm making good use of is just the engine's existing things. So let's dig into the world editor and see if there's anything obvious we can use for this. So it's a blueprint, so I kind of like the idea of having like maybe a panel. Let's see, atmosphere, nah. Those don't look like they're valid things. Cameras, no. Cursors, let's see, maybe there's a cursor? Not particularly. Close. Some of these are close to what we want, but not quite. For now, I'm actually tempted to just use either the plate, or we'll see if there's anything else real quick. But I don't think there is. At least nothing that we're gonna want to make use of. Yeah. Oh, actually, let's use the water block. I kind of like that, having this nice little blue square that tells us, hey, this is what a blueprint is. And we'll edit the what they call the balloon string, which is essentially when you mouse over, what words does it tell you? There we go. That looks good. And you can see we can attach mutators to it, but I don't see any need to. Mutators I think of as something that are kind of better for the game than for the editor. So we've got that in place. So now we're going to hop into our editor page. And we need a new enumeration so that the current tool can be set. We also need a button observer, and this will be our blueprint button observer. We will handle the blueprint button effect inside this function. That should really be all we need. That should be fairly simple. Oh, we will need a manipulator for it. And these are things I'm pulling from the engine. And you'll notice there isn't really good code documentation, or even like my organization is even failing a little bit here. And that's mostly because this is editor code that I don't care a ton for. This is something that can be a little bit ugly, and I can get away with it. Obviously, I don't want all of this to be the ugliest thing ever, because I do need to come back in here and modify and kind of maintain it every once in a while. And I'm looking for the manipulator here, because I should kind of clarify, I guess. The editor creates nodes and then attaches manipulators to them so that you can twist and do all the transformations and cool stuff to nodes, so that you don't have to have a bunch of extra functionality that lives in your game code in order for this to work. And it looks like the fog space manipulator code is pretty simple, which is good, because I don't want to spend a ton of time just getting this added into the editor and get it all working. No, I just want a simple, quick little thing that kind of copies what happens in the engine and does its own thing well enough. So this is not a fog space, but a blueprint space manipulator. And you can see I'm just doing quick, like, copy and paste stuff. Like I said, I don't care a whole ton for a lot of the stuff going on in here, and that's alright. I can be a little messy and a little lazy, and nobody's really gonna ding me for this, because this is actually code that is not going to be in the final game, ever. This is something that, unless I go into, like, the Steam Workshop system, and even then, that's iffy. I really don't want to open the engine up in this way. So what's probably going to happen when I make the final game is this is part of, you can see it's part of its own separate project, and it builds its own DLL that is not going to be linked in as part of the final game. It's just not, the code won't even exist. So I can make this as messy as I like, I can make it crash all the time, and this will never affect an end user, which is really cool. If you ever end up making an editor, I would say go for something that splits off into its own like this, because you avoid a lot of the trouble that you might otherwise run into. And it's still a fairly simple solution to apply. I'm just trying to make everything kind of uniform here, make even my comment lines look at least okay. There we go. We need to blueprint space. Oh, and of course, since the blueprint space is used, we need to include spaces.h so that it knows what a blueprint space is. And since the engine doesn't use the name spacing that I do, we have to go in and add the name spacing to each of the objects that the engine would use. There we go. And this just kind of ensures that if I ever make an object of the same name as the game, that the game object never causes a name collision with the object that lives in the scene. Okay, so we've got our blueprint space. I don't know if I'll need the fog space object the same way that the fog space uses it. It uses it mostly for serialization purposes, and also to kind of hold things that you don't want living in the base class. For example, the fog space flags, the fog's color, its density, like none of that actually exists in our space. So there's no reason for us to hang on to this. It's just kind of a bit of extra code that doesn't do us anything. I can't really think of any use for it at the bare minimum. If we were to try and utilize an object inside of our space, I can't think of what it would hold. So I think we're fine without one, as is. So let's see here, fog space. And the other reason we don't just inherit from the fog space is you can see inside the engine he's marked it as final, which essentially tells us that as a programmer, the engine's author intended for nobody to ever subclass off of this. This final keyword not only is a kind of a compiler command, but also, once again, I keep talking about good code intentions, or showing your intentions through code. And this is a great keyword that essentially says, yes, this class does exist, but I want it to be the final leaf in a tree that you cannot continue to subclass from. Otherwise, you will break something. Not the end of the world. It's actually honestly fine. We just need to do a little bit of copy and paste to ensure that some of this makes it through. Yeah, okay, we want those. And these were marked as private, so we'll keep them private. Let's see, what else do we have? Or does he have that we don't? Fog space size being its, and we don't want the C4 API as a macro he's defined to essentially ensure that his DLL is exported correctly. And that's something I'm not really going to dive into right now, because DLL exporting and importing, same as library exporting and importing, can be a very, very heavy subject, and it's not really something we want to dive into right now. I'm just going to copy these over for now, although I honestly can't think of a good use for them. In fact, I don't see why we would want to override preprocess or neutralize. We do probably want to just make sure. I'm going to put these in here, and I'm not going to fix them up and make them pretty for now, just as kind of a reminder. In fact, let's make this compile, but leave the reminder there. Leave in the reminder that there might be something I need to remember. For example, I most definitely will need this pack and unpack. So let's leave that in and make it pretty first. There we go. Nice and pretty. And compiles. Not really. What is going wrong? Why don't you want to compile? Ah, because you have functions that I honestly don't care about. Blueprint space. Inaccessible base class. Interesting. Ah, and here's our problem. We have not marked this as public. So if you don't mark a subclass type as public or private or protected, it is assumed to be private, and that means it's going to put up all the standard barriers that our protection will allow us. So nobody would be able to see that our blueprint space subclasses from space, even if space has public functions, because we marked the inheritance as private or protected. Marking it as public kind of allows everything to see it and see that it exists. Now I saw there's a lot of stuff in here that we need to continue to add just to make sure this is all happy. For example, we added a new button observer, so we need to add that initializer to our stuff. And I don't really need that code or that commenting sitting around, so I'm going to rip that out. And we need this private function. And this is kind of the downside of C++. In C# you can mark something like this as you do private right here. And it would kind of let you know that this is a private function. C++ doesn't allow such a thing, because header files already designate what is marked as private and what's marked as public. And you don't really want the two to ever be able to go head-to-head with each other. And we're just going to do kind of the same thing that we've got. Set current tool, yeah, that looks fine. Let's make sure we didn't miss anything. We've got our manipulators, and that looks fine. We've also got, I'm going to just quickly dig through the game editor page and kind of make sure that that everything in here is included. For example, here, what is going on here? Ah! We have, what do we call it? We called it our blueprint button. Effect button observer. I actually don't quite understand what's going on here. It looks like we're trying to put the identifiers into an array, and then we're setting all their observers to the same thing. Which suddenly makes some sense. I may not actually need to copy and paste that code. Let's try without. Let's see how simply and easily we can do. And I'm just going to name this handle button effect to make it a little more obvious what I'm going for here. And you are named correctly now. Okay, so let's go through. You look fine. Disengage. Begin tool. Okay, so we need to add a new case here. A new case statement. Ah, and of course I'm pressing 1 instead of pressing up like I expect to. We need to... Music just got really loud. Thank you, music, for getting very loud in a moment when I was... Okay, you know what? I'm just going to crank it down a little for myself. I hope the audio levels are still good for you guys. And good morning, Paradise PX. just kind of doing my thing, making games. We'll see how long I last this morning before I decide that a break is in order. I'm somewhat tired, but it's not the end of the world. So the same way we have kind of a null effect pointer sitting around, we're going to do the same thing here. And we're just going to say the space is a new blueprint space. And we're just going to set kind of a default size to it because there's no really reason not to for now. We're just doing something simple to kind of get this all in place and ready to go. If space, and we put the new space node in. Okay. I'm slowly starting to understand what this plugin does, because I wrote this a long time ago. Like, this was back in almost my college days when I wrote some of this code. So if I'm kind of spending a lot of time staring at this, wondering just what in the heck I was doing, that's kind of why. Luckily, this code still works, but my understanding of it has diminished somewhat significantly. So I'm kind of looking through a lot of it and realizing just how much work that this little project is generating. Because this should be a fairly simple thing, right? Granted, we're doing a lot of work so that we can do the authoring in Engine and then move that over to a very simple system inside of our game. And I'm kind of wondering if maybe we shouldn't put off the authoring stuff for now, just for the sake of having something working. Because as much fun as this is to get this whole thing up and running and kind of plugged into the game engine as an authoring tool, it's not really a necessity, right? We're trying to trim down all the extra garbage that I'm doing, because I, as an indie game developer, need to be kind of ultra productive. I can't spend a ton of time on tasks that aren't going to yield a lot of results. Which is kind of why I'm sitting here going, maybe I could be doing this better. Maybe I could be finding a better way to do this, right? Because if I spend time on a solution and end up scrapping it, that might be a couple, like a small gameplay feature that isn't going to make it into the game in the end, because I'm running out of time or want to publish the game sooner. Granted, I don't have any of those actual deadlines ever, because as an indie game developer this is my hobby, I can take as long as I like. I do have a full-time job on the side, so it's not like I'm short on cash or really need to wait for something to kick in for like a contract. So I'm not in any kind of time constraint, but I do still want to be as efficient as possible with my time, if only because I'd rather the game come out sooner rather than later, so that those of you watching can eventually subscribe or just play the demo game as I put out download links, that kind of thing. I just don't want this to take too long. Of course, starting work and then just kind of giving up on it also is not a good way to spend my time either. So let's see if we can finish this quickly. I am noticing there's a lot of work attached to this. We are going to see if maybe we can shorten that amount of time somewhat by being a little smarter about how this works. We simply have to do a little bit more extra work on ensuring that we have the right tools for the right job in place. And I'm thinking that a giant monolithic thing for now is not the end of the world. Note how I'm kind of going against what I was saying earlier in terms of we don't want giant monolithic tools sitting around. I'm actually going to create something that is more than a little bit ugly, just for the sake of saving myself some time right now. there we go. I was kind of hoping this task would be a lot faster and easier, but I guess as it turns out, programming is never quite as quick and easy as you would hope. So Paradise PX asks, do you use reflection to create your blueprints, or is it already implemented in C4? The blueprints right now don't actually exist, which is why you notice this like space class is mostly empty, right? I've not actually implemented anything here. This is just a giant blank CPP file where I've declared my innards, but I haven't defined them yet. Hopefully, you know, for those of you who know programming already, I don't annoy you with these basic terms. But for all the new people watching, essentially the idea of declaring something or saying it exists versus actually having executable code that runs that class, that we call kind of defining it. Think of like a dictionary when you look up the word in the index, and then you actually look up, you know, because people still look up things in actual book dictionaries these days. But the idea is that you have the declaration that the word exists, and then it tells you like all the details about it. Oh, it's a noun. Oh, it can be used in this case. It's a past tense, you know, verb, whatever. And then you actually have the definition of the word in the dictionary that tells you what that word actually means. That's kind of the same thing that programming goes for. So just to actually answer your question, blueprints are something I need to create. And I'm not really using reflection right now. I'm just using a, what's a good term for it? A 2D flattened version of the 3D model. I'm just creating a little 2D square that says this is the space that this building is going to take up. And hopefully we'll be able to finish this and get it into the game so that you can't build things that like hang over cliffs and that kind of stuff. We'll see if we actually get to that part, because as I said, this will be a somewhat short morning stream, depending on a couple of things. I really want to get this done though, so let's get back to work. We need, let's see here, track tool. So we need to figure out where the, fog space track tool code is. So I'm just going to look up in here. Here's the lights page, the zones page. No, we want, it's not a zone, it's not a light, it's not a portal. Effects, no. Where is it? Where has my little function gone? Where could it be? It's not a path or a marker or a trigger. Is it really? It might be in the zone, but I don't think it's a type of zone. No, it's not. Okay, definitely not a zone. I apologize, Paradise. I don't actually understand your question about Unreal Engine using blueprints. So the idea of what I'm calling a blueprint in this case is actually little more than just kind of a footprint. That actually might even be a better term for it. I might want to swap its name to a footprint, because it's less how something is built and more the ground space that an object takes up. Hopefully that makes a little more sense. And I really can't find the tool for setting up these spaces. This is bizarre. Okay, cameras, drag rectangle tools. Where do you exist? That is in a box select tool. Not really my style, or at least not what I think I'm looking for. Node scale, rotate, move. Maybe it just doesn't have a special tool, which would be fantastic. If I could just like call a base class and be like, yeah, just do your normal thing. That'd be great. Triggers, markers, portals, sources. No, it's not scripting like the blueprint system. It's more of, yeah, like I said, it's more of a footprint than a blueprint. The scripting system in C4 is pre-implemented, and it's not something I have to generate. let's see, there is a fog space manipulator, yes, okay. And I've got that space manipulator already put in here. And just to double check, I also have... Yeah, I have to fix this up, obviously. So let's get that done. K-space interior and outline color. These look like something I will need. Yeah, that is definitely something I will need. Where is that interior and exterior color? Here it is, inside space manipulators. Makes actually perfect sense. I don't know why I didn't look there first. And let's put this down actually by the code that it affects, just so that, just so we're not going out of our way to do anything too crazy. And once again, stuff exists, or the code that I copied and pasted needs to kind of match or fit the... currently it uses the engine's way of naming, and I need to quickly rename space things. Not the end of the world, but definitely something I have to think about. Also, it looks like the plate size is actually stored inside the fog space object, which might be a use for the object system. Even though it's bizarre, you have the world vertices out here, so why would you re-implement them inside this fog space object? That actually doesn't make much sense to me. But there's the flags. I'm not... Oh, I'm guessing because it's a plate volume space object. I think I understand a little bit better. I'm not such a huge fan of this. Sometimes the way the engine uses and creates objects is a little beyond my comprehension. And this is very, very quickly becoming something bigger than what I wanted to dive into right now. So I'm going to put this on hold. And I'm going to do so by just simply commenting, no, I'm going to do this even better. I'm going to do this cleaner, just to make sure I get this right. So a neat thing you can do, and I'm sorry for jumping all over the place like this, I didn't really have a big plan for this morning. I was just kind of, I wanted to get something done, and in getting something done, you know, I show you guys, just in case anyone is online, just to kind of see what I'm doing and keep up with the work. So I'm going to do something called creating a patch, and what a patch does is it uses my current code backup and only records the changes I have currently made into a single file, and we're going to call it a patch file, and it's going to be the blueprint space patch. And what this essentially does is it allows me to throw away my changes and then come back and work on this later without losing any of the work I've done. So we're now going to hop into the subversion system and undo all that work we just did, right? And we're going to have to reload the project and a whole bunch of our files, and it's fine. Black Soups, this is the C4 engine by Terrathon. I think I should have a link in my text description underneath the stream. It's essentially a C++ engine that makes very, very heavy use of good inheritance techniques, and especially uses a lot of authoring tools that are inbuilt to the engine in order to make life easier for small teams. So we're just going to jump out of the idea of authoring this so much, and we're going to jump into the idea of using the points on its bounding box to ensure that this stays within a single cell. So this requires some work that is going to be attached to our game tool. And the question becomes, where and how do we put this in? So when we're tracking, let's see, when we're tracking or when we click. So we need one check when we click to make sure everything is all right and that we're actually in a valid space. And we also want some kind of tracking check to ensure that you can't do anything too stupid either, or that the player is notified, I should say, when they're about to try something stupid that the game is not going to allow. So the first obvious thing we can do comes out of this game world, or this begin check. And let's see here. What are we going to add in? Morning.
Yep.
Going shooting?
Food.
Food. Ah, got it. So we're going to grab the bounding box off of the... We've got kind of this generic model loaded already, this shed blueprint model, and we're going to grab the bounding box off of it. Get bounding sphere. Bounding sphere isn't quite what we want. We should be able to get a 3D bounding box off of it. The question is, where is that bounding box? And that, my friends, is a good question. I honestly don't know. It might live inside this object, although it doesn't look like it does. Although it looks like we can get the size, which might honestly be all we need. That doesn't look like a right kind of size, though. Alright. Documentation, come here. I'd rather not dig and look forever inside things that may or may not. We're just going to look up bounding box. Obviously, the class exists. There's a box 3D class. Here we go. Calculate bounding box. That looks like something that's promising. A pointer to the location where the bounding box is stored should be overridden by any node that needs to calculate its bounding box in some special way. Should return false if the node does not have a bounding box. That might be what we're hunting for, but I don't actually think it is. The problem is we don't have anything a ton better that is making itself readily apparent. Let's see here. Node transformations, bounding sphere. Once again, bounding sphere, but that's not exactly what we want. So I might actually try this calculate bounding box function and see if that gives us what we need. So let's see. For the calculate bounding box function, we need a box 3D. We're going to call it bounding box. And then we are going to hop into our shed blueprint model and call calculate bounding box. And we are going to pass it a pointer to the bounding box for it to fill in. Alright, so now we've got our bounding box. We now need to check whether or not the bounding box has all 4 points, the 4 bottom points specifically, are over the same Verneuil cell in our game world. So let's see here. First, let's double check. I want to make sure this all works before I kind of dive in, making a bunch of assumptions along the way. Because when you start making assumptions like that and things go wrong, you tend to have to do a whole lot of backtracking that I'd rather not have to do if I mess something up. Alright, so let's see here. I'm going to just simply grab this node and I'm going to slap it down. And so here's our bounding box. And if I look at the innards very quickly, they're all zeros. Actually, there are a bunch of crazy numbers. It's all garbage data, which is expected. Whenever you initialize something like this without calling the constructor, in most cases, if your compiler is smart, or if you're using something that is an optimized system, it's going to simply assign the memory onto the stack without actually setting any data. Because setting data takes time. If we were to go through this bounding box, which, let's look at the declaration for a moment. Nope, not there, not there. Where is your declaration bounding box? Here it is. It's a range of 3D points. So that means it's a pair of 3D points are what define this bounding box. So if you think about that, okay, point 3D is 3 floats a piece, and we've got 2 of them. So that's 6 floating point numbers. So if I just generate this box 3D class without doing anything such as initializing it, I just set the memory aside and fill it in later, that's going to be pretty quick. But if I say bounding box and expect it to zero everything out, kind of like, I think actually C# does this. When you declare a variable like this, it actually fills the stuff out, and that takes a little bit of time because it has to go in and set each variable, each of those 6 floating point numbers I was telling you about, and it sets them each to 0 one at a time. And that takes time. Something that would slow down our game, and we're trying to keep ourselves at least above 60 frames per second. Performance isn't a huge worry, but it's still a little bit of a worry. So I'm looking at the details of this bounding box, and it doesn't look like anything got really added to it or set inside of it, which is somewhat worrisome. I'm kind of afraid this function doesn't do what I think it does. So I'm just going to try it again, but this time I'm going to step into the function. And here's a problem. It's just returning false. It's not setting anything inside the function. But there are a bunch of points. Let's see here. I see a bunch of ways and spaces that have overridden this function. So you would think, let's see, is there something easy here I can use? So I'm looking at all the various types that we've found and trying to find one that has a good calculate bounding box function that we can make use of. Unfortunately, I'm not finding one. I'm finding all kinds of manipulators and all kinds of other stuff. It seems like pretty much every other space in the world generates some kind of bounding box, but this object does not. So we're going to have to get a little tricky, a little cute, just to get this to work. So let's see here. I'm actually not, I need to just generate at this point. So I'm going to open up a new world, and I'm going to load our ghost shed model into this world. And I'm actually going to save it finally, because we're going to do some tricky, kind of cute-ish things with it. Because this is the node we are using currently to describe what our shed is not only going to look like, but now we're going to add in a little extra piece that will essentially tell us where this node takes up space on the ground. And that looks pretty good, right? That little white square underneath, that looks like a good approximation of where this model takes up space on the ground. You can see we have a little extra space on this side, but that's not the end of the world. And so this is not going to render at all. In fact, it is going to be, let's see, somewhere in here, we can mark it as completely invisible. So we don't want any kind of animation on it. And all of the masks we can kind of leave on. Because the big thing, so, where is it? Somewhere in here, I swear I can make this. Oh, here it is. Geometry is invisible. So what we're doing is we're adding a piece to the world that says, I am invisible, but I am going to have a name and a type that allows me to quickly be found, and we are going to use that to query whether or not it's on a valid piece of ground. And this is kind of I hate to say it, but it's kind of a hack. We're breaking the system and using it in a way that is probably not completely expected right now. And that's fine. We don't want it to have any kind of collision detection. We don't want it to really even exist in this world. We just want it so that it can exist and tell us where its four corners are. So you can still kind of see the wireframe here, this white wireframe. That's all that we really want this for. All the other properties of this can go right out the window, which is kind of why I wanted this to be its own custom space. But for now, we're going to throw that all out, and we're just going to try and get this done and into the game so that the functionality shows. Because right now, this is an annoying thing that you can do in the game, and doesn't really, it doesn't add anything for me to allow this to continue. In fact, it detracts from the game that I can do this. So, this is going to be, not the blue, I'm actually going to call this the footprint. It's a good name for the node, the footprint. And we're going to save it back out to our model resource. And you'll notice it is in fact invisible. You can't see it until I click on the node. And it shouldn't show up or do anything to our world. You shouldn't even be able to notice it's there. That's the hope. So, let's see. How do we do this? We need to, when this tool gets created, we don't just want, where is it? Here it is. We don't just want this like generic model pointer, we also want the stuff that's underneath it now. Now we need to recall that there is a plate geometry, and this is going to be our footprint geometry. And we need to initialize this. Let's see, can we just find node based on the name? Yeah, we can. There it is. We call it footprint. That's all we need to know. So that should do. Especially since we just need to static cast it to its right type. There we go. That looks much better. So we've got that. And since this isn't something that is being explicitly created via a new, we don't have to delete it. So we're just going to set the null pointer to it when we destruct the tool. Alright, so we've got this footprint geometry, and we can now, apparently we can't call calculate. There we can. I can call calculate bounding box on it. Why are you complaining? What are you complaining about now? Cannot access private member. Private? That's unfortunate. Why is it declared as private? I want to be able to access this. Once again, the engine keeps kind of throwing things at me that I don't expect it to. Why are you private is the question. And also, why would you override a public function to make it private? It makes me wonder if maybe he doesn't expect this to be used anywhere except outside the engine. Either that or the information exists elsewhere in an easier format. And it looks like it does. Here we can actually find, here's the plate size. So that makes sense. See how code intention kind of tells us what we should be expecting? It lets me look at code and easily parse and figure out what I should be expecting this code to do. So when I looked at it and said, well, why are you overriding it and making it private? There's some intention there that I'm not understanding. And so when I look at the code further, it turns out that information is not only accessible elsewhere, it's easier to access elsewhere. And that is where. And of course, Visual Studio likes to torment me, so it's damaging my code as I write it. Whatever. We shall persevere. Okay, so we've got the plate size. The only other thing we need to do here is translate this plate size by the node's current position. Not difficult. We say plate size. We're actually going to create a position out of this. And we're going to call this the footprint position. And it's going to be the footprint geometry's world position. And and we need to convert that to a vector or to a point 2D, because we don't really care about height, right? We can get height from the terrain. We don't honestly care about it. We're looking at this from the top-down position, and we're essentially trying to make sure that the 2D points are all on the same cell in our geometry. So plus plate size. Great. World position. So this is the center, right? This is the center of our footprint. So now we're going to get the cell pointer. Let's see, we have to go into the, we'll call it the footprint cell. So this is the cell that the footprint's origin is hovering over. Let's see here. Game world. Get terrain cell graph. Get cell. Yeah, and I can just do that off of a point 2D. Footprint position X. Footprint position Y. Fantastic. So this should give us a valid cell. Now we need to make sure that each of the 4 corners continues to stay within that cell. Otherwise, we know that we're hanging over an edge somewhere, and we don't want that to be the case. And I just realized I shouldn't actually be adding the plate size there. So we need our 4 corners. And we could do some clever stuff to put this into a for loop and make life a little easier for us. Essentially, the way we're going to count is 0 is going to be our upper left-hand corner, and we're going to go 1, 2, 3. So if we're going to count, essentially anytime the number, the index, is odd, we know we're on this right-hand side, and anytime the index is greater than 1, we know we're in the bottom row. And you can do this for graphs of any size. It just makes it stupidly easy to explain for a 2x2. So we're going to grab the corner X, and that's going to be the footprint's X position plus, and here's where that cutesy stuff comes in. If I, let's see, I mod 2, yeah. If I mod 2 is 1, which essentially is if this is an odd number, because remember, modulus is essentially what is the remainder of the divisor. So you say I mod 2 is I divided by 2, return the remainder. So if I is 3, okay, I divided by 2 is 1 with a remainder of 1. So I mod 2 equals 1. If you want more details on how modulus works, I really suggest looking it up. It's a great tool that is very underappreciated in the programming world. So if it's odd, we know we're on that right-hand side. So we're going to add half of the plate size into our X. Otherwise, we're going to add negative plate size.x times 0.5. And we can actually simplify this even further. Let's actually take the calculation out of the branch, and we're going to say it's plate size times 0.5 times either 1 or minus 1. See how we're getting cute here? And if I say something and I say, oh, it's cute, see how we're doing it, and it makes no sense whatsoever, please call me out on it. This is stuff that I take very much for granted. I did a lot of 2D game programming before I dove into the 3D world, and so stuff like this for me is almost second nature. Versus for somebody who's just getting into programming, this might actually be something really cool to wrap your head around, but at the same time it can probably also be equally confusing if it doesn't make sense. So if you have questions, please ask. And we're going to do the same thing in the y direction. We're just going to say, instead of we're saying I mod 2, we're going to say if I is greater than 1. and then 1, and -1. I actually think I might need to swap those. Let me think for a moment. Let's see. If the plate size is greater than 1, then we multiply it by 1. Otherwise, yeah, no, that looks fine. Cool. So now we've got the corner X and Y. So we're going to check if that's in the same cell. So we are going to grab a new cell pointer. And you know what? I'm actually going to pull the cell graph pointer out to here. Because we're calling on it a lot, and we don't want to keep dereferencing the world every single time we do this. So you'll notice here I've moved that variable out to there because I also have every intention of using it here. And each time you do that dereference, once again, we're spending CPU cycles doing something that we would probably rather the game is doing other things for. And then we say if the two cells, so if the footprint cell is not equal to the corner cell, so if we've generated, essentially, if our center and our corner are on two different pieces of terrain, something is wrong. So we're just going to toss a Boolean at the top of this whole thing that essentially says is valid. And we're going to assume it's valid until we figure out otherwise. And here's the case where we find otherwise. We say, oh no, one of those corners is bad. And then we go through and we say, well, if it's valid, sure, create the node. Right now, we have no good way of telling the user a bad, that a bad piece of terrain has been attempted. So we don't really have an else here. We should have some kind of else here. Some way to, tell the player to do. Tell player placement of building was invalid, right? Because, you don't just click and nothing happens. Otherwise, a player kind of sits there and keeps clicking and wondering what the hell is going wrong. At bare minimum, we should probably have like a wah-wah kind of sound, just so that they know, oh, I didn't do something right. Instead of, why isn't this game working, and getting frustrated at it. The last thing we want is someone like Total Biscuit wondering why the heck this game is not doing what he's telling it to do. So, right now the game breaks. I must not be doing something quite correctly in here. I'm going to put a breakpoint in here and we'll do a quick bit of debugging. This is kind of how most of programming works. You write code and then you test out, okay, let's test a good case, right? Let's find this. This is a valid case. So we click and intuitively we know this is a valid case. The question is, why is it crashing? Also, the question is, does the code do what we think it should do? So it looks like our footprint geometry is not being found. That is my guess. So I'm just going to click, put one down, and if we look at this footprint geometry, yes, this is a null pointer right here. That is not good. Which means this is not working as expected. Let's double check that, okay, yeah, it's named footprint, and it's there. Did we save it to the model resource? That is a good question. If we didn't do that, it won't show up. Let's try this again. We're going to load it. The blueprint model has the shed. If we do the find node, nope, it's still null. So something is wrong here. It's not finding this node quite correctly. We might have to simply loop through it ourselves. That might, I don't like to do that, but maybe find node doesn't do what I think it does. It's a very real possibility. So I don't need to dig through his hash function. I don't understand exactly how it works. It's a standard hash function. it turns characters into an integer of some kind. Fine, whatever, I don't really care. The model hash table is null, and there's our problem. So it's not actually generated this detail yet. So we can't just find node inside of it and expect to hunt down what we're looking for. So 2 questions we could ask. One is, why the heck isn't that node table valid right now? Question number 2 might be that maybe instead of trying to find it the, cutesy way, that we can instead just find it the old-fashioned way. And I think I'm just going to do that for now. Node pointer. So C4 does support PS4 exporting. It also does Linux and Mac. It's OpenGL based, so it can support all kinds of crazy stuff. I do hope eventually that I make a game big enough that putting it on the PS4 would be a possibility. That would be really cool. But one thing at a time, let's just kind of get this working. If subnode get node name